Hello and welcome. This is the fourth video of an intuitive introduction to statistics series. In the first three videos, I have discussed some foundational concepts like data, variables, and levels of measurement. You can watch all the videos of this series by following the link given in the description box. Now is the time to introduce another foundational concept, sampling. So let's see what sampling is. In the previous videos, we have discussed a data set containing data about students' names, genders, age, city, number of siblings, and income level, etc. We need this data to make certain decisions. We can collect this data from students. However, we don't probably need to do that because most probably this data has already been collected at the time of admission by admission department. So we can simply get this data from admission department and use it for our own purposes. Such data, which has already been collected by someone else for some other purpose, is called secondary data. For example, this type of student data or point of sales data, which is generated when customers check out at the counter. However, we do not always have secondary data for everything, and sometimes we need to collect our own data for the study or for whatever purpose we need it. For example, if a university wants to get an idea about the student satisfaction levels, it might need to conduct a survey. This data is not already available anywhere and has to be collected. So this type of data is called primary data. However, collecting primary data is a problematic issue because suppose they take for example the university at which I teach, it has at any time more than 50,000 students enrolled. So if the university wants to get opinions of the students, it is going to take a lot of time to collect data from 50,000 students, and a lot of costs will also be incurred in terms of the time and resources. So what do you do? Is consider another example. A factory makes tires, and you want to test every tire to see how durable it is by subjecting it to stress testing. However, if you do so, a lot of time will be required, a lot of cost will be incurred, and additionally, it will lead to the destruction of the tires which are tested. So, at the end of this testing, no tire will be left for being to be sold, which is of course not a desirable situation. So what do? You take a sample. But what is a sample? To understand what is a sample, we first need to understand what is population. So the population refers to the entire group of interest. For example, all students at University X whose opinions we want to know, or all tires produced at a factory in a month, say 100,000. So these 50,000 students or 100,000 tires are the population. But as we discussed, we cannot always collect data from the entire group of interest. So we take a subgroup from that population. For example, we might decide that we are going to select 1,000 students and get their opinions, or we might decide that we will choose 100 tires and subject them to stress testing. Those 1,000 students or 100 tires is our sample. However, the question is, which 1000 students or 100 tires will we select? There are 50,000 students and we have decided to collect data from 1000, but which 1000 students or which 100 tires? Oh, so there are many approaches which we can adopt. The first and the simplest approach is to get data on the basis of convenience. For example, we go out and interview the first 1000 students we come across. This is the easiest way, but it is highly problematic because it will probably result in a sample that is not representative. That is, it might have some gender or departments might be under or overrepresented in our sample. For example, we might end up collecting data from 800 male students and only 200 female students, or we might end up collecting data because we are collecting data on the basis of convenience only from 3 departments out of, say, 70 departments. So, the opinions of male students cannot be thought of as being representative of the female students. Our opinions of 3 departments might not be applicable to the to other departments. So convenience sampling has obvious limitations. So, one work around this problem is to assign quotas. For example, we might have an idea that there are 60% female students in our university, so we decide to maintain this 60-40 ratio in our sample, and we decide to include 600 female students in our sample of 1000 and 400 male students. So, so what we do in quota sampling, we first assign quota to each category, for example, gender or department, and then select student on the basis of convenience. So we have decided that we are going to include 600 female students. However, we select those 600 female students on the basis of convenience. This, although more representative from simple convenience sampling, then simple convenience sampling is still not fully representative. So we need another approach. Another approach can be simple random sampling. In simple random sampling, we will list down all the students and then use a random number generator to select the students. Random number generator might suggest that we should select, say, first, 32nd, 105th, 320th student, and then we will go to those students even if it is not convenient. So this is done to rule out our own bias, but this can be costly or sometimes even infeasible. For some populations, we might not have a list. For example, if you want to get opinions of the customers at say fashion clothings, you do not have a list. So this is simply not possible. This approach is not applicable there. Additionally, it still might not result in a representative sample. For example, out of 1000 students, 500 might be selected from first 15,000 students and only 500 from next 35,000 students. So, simple random sampling, although a lot better than convenience or quota sampling, is still not the answer to all of our problems. We, to overcome the problem, some of the problems in simple random sampling, we can use systematic random sampling, in which we choose the first one randomly and then every nth. For example, suppose we decide to collect data from 500 students or say 500 students. So we now know that we have to collect data for we have to select one student from every 500 student. So we select the first student randomly, which comes out to be 13, and now we are adding 500 students. After 13th student, we are going to select 513, and after that 1013. This can again be costly and infeasible because we might not have a list. Another approach is stratified random sampling. In stratified random sampling, we first identify the subgroups, which we call strata. For example, we might decide that BS or undergraduate students and MS students and PhD students have different kinds of problems. So we should try to ensure their representation in our sample. So we first decide our strata and then randomly choose from each subgroup according to its share in the population. Suppose BS students are the 80% of the students in the university. So out of a sample of 1000, we are going to select 800 students from BS programs. This is called stratified random sampling. It is different from quota sampling in its approach of selecting the students. In quota sampling, we also decide the percentage of categories, but from within each category, we select members to be included in the sample on the basis of convenience. But in stratified random sampling, we do not select on the basis of convenience. Instead, we select randomly. But stratified random sampling can sometimes also be very costly. So another approach which can be applied in some situations is cluster sampling. In cluster sampling, we first divide population into naturally occurring clusters. For example, in case of a university, naturally occurring clusters can be departments. And then we randomly select a few clusters. Suppose we randomly select 10 departments out of 70, and then we go to those departments and interview all the students. This is different from stratified random sampling. In stratified random sampling, we select respondents or members for our sample from each strata. But in cluster sampling, we select the entire cluster. So cluster sampling is not same as stratified random sampling. In stratified random samplings, the sampling happens at individual level, but in cluster sampling, the selection happens at the level of the entire cluster. Another approach which might be very suitable or the only feasible option in some cases is snowball sampling. In snowball sampling, we first identify one or few participants who then refer to the next and so on. This is called snowball sampling because just like a snowball, as we move forward, our sample grows. It is highly effective. In fact, it may be the only feasible approach in some cases. For example, if we want to reach some members of some hidden population, suppose a university wants to investigate the problems or the factors or opinions of the students who are addicted to some substance. So there is no list for them. However, one student who is addicted to a certain substance is likely to know other students who are addicted to the same substance. So we select one student, and that student will then lead us to other students. This is called snowball sampling. These sampling approaches can be classified into two broad groups, which are referred to as probability and non-probability sampling techniques. In probability sampling, every member of the population has a known, non-zero chance of being selected in the sample. But in non-probability sampling, some member of the population have no chance of being selected, or their probability of being selected can't be determined. From the approaches we have discussed, convenience, quota, and snowball sampling are the examples of non-probability sampling, because in these approaches, some members have no chance of being selected, or we do not know the probability of them being selected. In contrast, in simple random sampling, systematic random sampling, stratified sampling, and cluster sampling, every member has some probability of being selected, which can also be calculated. So all of these approaches can be classified into two groups, non-probability and probability sampling. So sampling is an important issue, is a very important subject in statistics. Thank you for watching the video on this topic.